Hi everyone, welcome to my another lecture on Cauchy's integral theorem. Cauchy's integral theorem. In this lecture, the learner will be able to understand what is Cauchy's integral theorem, how to prove Cauchy's integral theorem, and using Cauchy's integral theorem, I will do a sum. Okay. So before this, I explained very nicely Cauchy's integral formula. There was three lectures. So I will request all of you, you have to see that three lectures, then you have to see Cauchy's integral formula. And I already explained very nicely Cauchy's integral formula for differentiation. That was three lectures. So I would request to everyone, you have to see my previous lecture, that it will be more understandable what is Cauchy's integral theorem and how to prove this. Okay, let's start Cauchy's integral theorem. That is, if a complex function fz, that is complex function fz. What is fz? Fz is a complex function, like z equal to x plus iy, z equal to x plus iy. So it is a complex function. If a complex function fz is analytic on a simple closed curve C, on a simple closed curve C. Closed curve means it may be a circle, it may be a square, it may be a rectangle, or any closed curve. Then integration fz dz equal to 0. This is known as Cauchy's integral theorem. This is known as Cauchy's integral theorem. That is, on any simple closed curve, on any simple closed curve, on any simple closed curve, okay, on any simple closed curve, that is C fz dz equal to 0. Okay, let's prove. Let's see the proof. Okay, since fz is a analytic function, so we can say fz satisfies CR equation. Okay, since fz is a analytic function, therefore fz satisfies CR equation. Cauchy's Riemann integral equation, CR equation. Okay, CR equation. What is CR equation? That is satisfies CR equation. Therefore, CR equation is del u del x equal to del v del y, and del u del y is equal to minus del v del y, del v del x, del v del x, sorry, del v del x. So this is the CR equation. So now let fz equal to fz equal to u plus iv and z equal to x plus iy. What is z? I already told, because fz is a complex function, so z equal to x plus iy we can write. So dz equal to dx plus I into dy. Now I am writing left hand side. So this you have to prove this equal to 0. That is integration C fz dz. So this can be written as, that is, what is fz? That is integration u plus iv, What is dz? Dz equal to dx plus I into dy. So now again this can be written as, u dx, that is, we are multiplying, open the bracket, that is u dx, this is C, this is closed curve C. So u dx plus I into u dy, u dx plus I into u dy plus I into v dx minus v dy. Okay, okay. So this is actually product of this and this. Now I'm just rearranging this, that is real part and imaginary part. What I am doing here, this is the real part. I am writing real part and imaginary part, just separating. U dx minus b dy, this plus I am taking common, that is b dx, that is b dx plus u dy. So this is equation 1c. This is equation 1c. Left side is integration c fz dz. fz dz. Okay. This is equation 1. This is equation 1. Now by Green theorem, what is Green theorem? You know, what is Green theorem? You know very nicely. What is Green theorem? By Green theorem, right? Therefore, by Green theorem, now by Green theorem, what? That this is Green theorem. P dx plus q dy. P dx plus q dy, this equal to P dx plus q dy equal to double integration, that is del q by del x, minus del p by del y, dx dy. Try to understand this thing very nicely. So this is the Green theorem. I am applying Green theorem on this and on this. Okay. So if p dx plus q dy equal to this is by Green theorem. So what is u dx minus v dy? Therefore, integration u dx minus v dy, this equal to double integration according to this formula. What is p? P is u. So p is u. Okay. P is u. So and q is what? Q is v. Okay. So p is u, q is v. So it will be s. Q is actually minus v. So minus del v del x, minus del v del x, minus del v del x, minus that is del p del y. What is p? What is p? P is u, minus p is u. So minus del u del y. Del u del y, then dx dy. Then dx dy. Then dx dy. But p equal to u, see, p equal to u, q equal to minus b. Now this part. Now this part I am doing now. Then after getting these two part, that is this part I got this, and this part, that is integration b dx plus u dy. This equal to double integration s. What is v? Compare this with this. V equal to q, p equal to v, q equal to u. So this can be written as, tell me, del u del x, because del q del x, that is q equal to u, so del u del x, minus del p del x, that is v is p, so del p del x minus del v del x, then dx dy. Okay. Now I am keeping these two values, that is this value and this value. I am keeping this value, these two value in the equation 1, in equation 1. That means here I can give, that is integration c, and here we are taking this is c also. Okay. So now I am putting this value over here and this value over here. So what I am getting here, I can write over here. Therefore, equation 1 becomes, that is this plus this plus this. Okay. So this plus this. Okay. So that means we can write, therefore equation 1 becomes, you can write, that is integration C fz dz, this is equation 1, is equal to, what is this value? This value is this, integration minus del v del x minus del u del y into dx dy plus double integration s del u, this value, okay, that is I del u del x del u del x del u del x minus del v del y dx dy dx dy, okay, okay, okay. So this, that is equation 1, okay, okay, this is equation 1. Now what I am doing here, using CR equation, that is, what was CR equation? Using CR equation, using CR equation, CR equation. What is CR equation? What is CR equation? Del u del x in place of del u del x, using CR equation, that is in place of del u, in place of del u del x, in place of del u del x, not working. Using CR equation, using CR equation, that is, what is CR equation? Del u by del x is equal to del v by del y, del v by del y, and del u by del y equal to minus del v by del x, del v by, this is x, okay. Okay, this is del v by del x. So now I am putting del u by del x, therefore this equation becomes integration minus del v by del x minus del u by del y, minus del u by del y is, that is del u by del y minus del v del x. So it will be plus del v by del x dx dy plus I integration, that is del u del x equal to del v del y minus, here is del v, because del u del x equal to del v del y, now this is del v del y into dx dy. So this and this getting cancelled, this and this getting cancelled, so this equal to 0, that is integration C fz dz is equal to 0. This proves that Cauchy's integral theorem, that is, if a complex function fz, that is, if fz is a complex function and it is analytic function, then integration on any curve, that is fz dz, is equal to 0 on any curve, any closed curve, simple closed curve, okay. So this we have proved now. Now using this theorem, I am doing a sum. Like evaluate, this is very, very important sum. This sum I have taken from university question paper, that is, using this theorem I am doing a sum. So this sum is very, very important, very, very important. I am telling here. So find, they are not telling, that is, in the sum they are not telling this is using Cauchy's integral theorem, okay. So find, they are asking example, find z square plus 5 dz, where number 1 c is mod z is equal to 1, number 2 this c, that is closed curve, c is mod z is equal to 5, number 3 c is z minus 3 pi is equal to 10, number 4 that is c is square whose sides are x equal to plus minus 1, y equal to plus minus 1. Okay? Okay? So whose sides are x equal to plus minus 1, y equal to plus minus 1. These four sums using this. Okay. So now you see what is fz here? Here fz equal to solution. What is fz here? See, what is fz? Fz is a polynomial function. That is fz is a polynomial function. Fz is equal to z square plus 5, which is polynomial function. Polynomial function. Fz is equal to z, which is polynomial function. As we know, when fz is polynomial function, then it is always analytic. If fz is a sine function or cos function, then we can say it is always that is analytic function, always analytic function. I already explained this very nicely. So I will request to everyone, you have to see my previous that is lecture, that is what is what is analytic function. Okay, that is here fz equal to z square plus 5, which is a polynomial function. So we can say fz is analytic. So fz is analytic. So therefore, when fz is analytic function, then according to Cauchy's integral theorem, therefore by Cauchy's integral theorem, so integration c fz dz is equal to 0. That is integration c z square plus 5 dz is equal to 0 for any closed curve. Like, so this answer is equal to 0, this answer equal to 0, this answer equal to 0, and this answer is always 0. So using any closed curve, we won't see when fz is a fz, that is this fz is an analytic function, then we won't see which is closed curve, which is closed. It may be circle, it may be straight line, it may be that is square, it may be rectangle. We won't see which is closed curve. When fz is an analytic function, then directly according to Cauchy's integral theorem, we can see the integration of on any closed curve, this will be 0. So answer of this question according to this closed curve 0, this closed curve 0, this closed curve 0, according to this closed curve 0. So answer of all these 4 questions is 0. Okay. So firstly, you have to identify. That means you have to identify whether fz is that is analytic function or not. Where fz is analytic function, then directly you can say the integration on any closed curve, that is fz dz is equal to 0. So I think everybody understood very nicely. If you like this video, then don't forget to hit the subscribe button and notification bell. Keep watching, keep sharing, keep commenting, and keep sharing with your friends. I'll come with my next video on Cauchy's integral theorem. Using Cauchy's integral theorem, only one or two or three sums I will do in the next video. Then I will finish Cauchy's integral theorem. Cauchy's integral theorem. In this lecture, what you have learned? You have learned that how to prove Cauchy's integral theorem, how to do these sums. That is using Cauchy's integral theorem. In the next lecture, I will come with my new video using Cauchy's integral theorem, how to do the more sums. Till then, bye bye. Thank you very much.